Okay, here's a short video on scientific notation. What it is, how it works. Okay, scientific notation is a very convenient way to write a really, really big number in a compact form or a really, really tiny number in a compact form. So here's how it works. If you need to put a number this is called standard notation. It's in standard form. If we need to put it into scientific notation, this is the rules. This is what you do. Number one, you move the decimal from wherever it is just to the right of the first number that you come to that is not a zero. Move the decimal from wherever it is to the right of the first number that you come to that is not a zero. Step number one. So here's the form scientific notation takes. Something, point, something, something, times 10 to the something. This is what we have to fill in. Okay. Well, look at this first example. This is 125,000. Where is the decimal currently? Well, this is definitely a whole number. It's a big number. The decimal is to the right here. This is where it currently is. So I'm going to move it to the right of the first number I come to that is not zero. And I work from left to right. So from left to right, the first number I come to that's not zero is this 1. So that means I'm going to move the decimal right here. Make that decision. Okay. After you say, okay, this is where I got to move my decimal, then you count. So see how this is going to be? This is going to turn into 1.25 times 10 to the something. How I figure out this power right here is I count. 1, 2, 3, 4, 5. There's going to go a 5 right here. The last thing I have to decide is this going to be a positive 5 or a negative 5. Okay. Well, if the original number, 125,000, is bigger than what this looks like after you put in scientific notation, this is going to be positive. I don't need to write the positive, but I am for emphasis in this video. Let's do the next one. 0.000001. All right, we're going to change this to scientific notation. Move the decimal from wherever it is, here's where it currently is, just to the right of the first number that you come to that's not a zero. So all of these are zeros. So I'm going to move it from here to over here. So in scientific notation, it's going to be 1.0 times 10 to the something. Okay, we have to count. I move the decimal 1, 2, 3, 4, 5, 6 times. Now I make the decision, positive or negative. If the original number was this, 0.000 is smaller, and it's definitely smaller than what I made it look like in scientific notation, it's a negative, it goes right there. So this is scientific notation. All right, let's do this one. Move the decimal from wherever it is to the right of the first number you come to that's not the zero, and that's a 7. So I'm going to move it from here to here. So it's going to be 7.21 times 10 to the count. 1, 2, 3, 4, 5. 5. Now, if the original number, which was this, is smaller than what this looks like, that means I need a negative right here. All right. 300 million. This is the number I have. Put this in scientific notation. Move the decimal from wherever it is to the right of the first number you come to that is not a zero. The first number I come to that's not a zero is this 3. Where's the decimal? Well, this is a whole number, so it's at the end. I have to move it from here to here. So in scientific notation, it'll be 3.0 times 10. Now I count. 1, 2, 3, 4, 5, 6, 7, 8. Then I decide, positive or negative. Well, 300 million is bigger than 3, so this is going to be positive. 2.13. This is going to be, 213 will turn into 2.13 times 10. Where's the decimal? It's right here. I had to move it 2 times. Will this be positive or negative? Well, 213 is bigger than 2.13. That is positive. 10,800. This will turn into 1.08 times 10. Here's the decimal. I moved it from here to here. I count 1, 2, 3, 4. The original number was 10,000, which is bigger than this. That needs to be positive. 0.0031. In scientific notation, this will be 3.1 times 10. I had to move the decimal from here to here. I moved it 1, 2, 3 places, but the original number was 0.0031, which is smaller than 3.1. This needs to be a negative. That's how you put something into scientific notation. How do you take it out? This is how you take it out. You simply read a map. It's like reading a map. Here's my map. I'm gonna move the decimal 5 times. If 5 is positive, I move it to the right, which is the positive direction. If 5 is negative, I would move it to the left, which is the negative direction. So, to put this number in scientific notation back into standard form, I'm gonna move the decimal 5 times to the right. So it's gonna turn into, you can do scoop method. This is where you make scoop, you put 1, 2, 3, 4, 5, and then your decimal's gonna go here. What you put in these empty things is 0. So this is 3, oops, not 0, 3, 2, 1, 0, 0, 0. This is what this looks like. I moved it 1, 2, 3, 4, 5. This is what this looks like in standard notation. It's like reading a map. I'm gonna move my decimal 3 times, but that's negative. I move it to the left. So this will go 1, 2, 3, and here's my decimal. You put zeros in the empty scoops. 0.00123 is what that's gonna be. 3, if they give you a 3, where is the decimal? It's right here, 3.0. Sometimes they write it like that. So there's the decimal. We're gonna move it 4 places to the right. This is 3, 1, 2, 3, 4. That's what that's gonna be. What if they just give you 10 to the negative 8? Where's the decimal? Well, this is 1.0 times 10 to the negative 8. So this is where you can find your decimal. So we're gonna move it to the left 8 times. So you can scoop it, 1, 2, 3, 4, 5, 6, 7, 8. Which is gonna end up being, okay, 0.1, 2, 3, 4, 5, 6, 7, and a 1. 10 to the 4th, it's the same concept. This is really a 1.0 times 10 to the 4th. We're gonna move it 4 places to the right. So this is gonna turn into 10,000. So that is scientific notation, putting it in, taking it out.